Welcome back, guys. We are going to be doing something a little bit different to the norm. So, my niece recommended this game to me. It's basically a puzzle game. It's actually a learning game, but you learn from doing puzzles. So, there are different categories, maths and science and that type of stuff. But we're going to be doing the logic puzzles because I think they'll probably be the most fun to do. So in this first lesson, you'll start learning the rules of logic by visualizing the relationships among things to place them in the correct order. By the end of this course, you'll be able to solve complex logic problems in a systematic way. This course constructs the critical thinking skills that are the basis for mathematical reasoning. Okay, it's called Brilliant, by the way. The app is called Brilliant. So if you want to play along, and there's a 30-day free trial. It's quite expensive after that. I think it's about £100 a year. You can only pay yearly, annually. So £100 or about $150, I think. So it's very expensive, but you can have a 30-day free trial, so you don't have to pay for anything, obviously. Right, evil core sentient robots are depressed and have asked for a change of scenery. The robots are being sent to an evaluation facility where they'll be measured and reassigned to new divisions. 3 of the robots are all from different models, have missing model IDs. Ray is not the newest. Okay, so Ray can't go there. Nook is the oldest. Okay. So that means Ray has to go there and Lex has to go here. Okay. Nice and easy start. I have a feeling it's not going to stay easy for too long. Right. My niece did recommend that I bring along some pen and paper with me, so I have got some. I might end up having to do some little scribbles to help things along, but I'll try not to use it if I don't need to. Okay, so the robots are being packed into a container for their next evaluation. Which arrangement meets these packing requirements? Loy is in one of the 2 middle spaces. Okay, so Loy is in one of these 2. Mig is left of Lex, right of Ray. So let's just put Mig here. Right, left of Lex, right of Ray. Okay. So they obviously aren't directly left and right, because in that scenario, Loy would not be able to fit in the middle. So one of these 2. So it basically needs to be there or there, and Loy goes in the other one. Ray is directly next to Mig. Okay, so that is the only possible outcome. Right, still nice and easy so far. At the evaluation facility, the robot races begin to test physical aptitude. The robots accurately self-report the results, but the information has to be pieced together. Marv and Lex do not place next to each other, so it's there or the other way round, which means Ray has to be in the middle. Ray beats Marv. Okay. Fastest and slowest. Okay. That's the only possible outcome. Nice and easy still. Right, the first clue was very informative. Marv and Lex do not place next to each other. What can you conclude from this clue? Ray finishes in the middle. That's right. Once you've discovered that Ray's in the middle, it's much easier to complete the puzzle. Start where you have the most information. When you're given multiple pieces of information, start with the one that lets you deduce the most. Nice and easy. In the next race, we have these clues. One robot finishes between Ray and Lex. Okay. So it has to be there, the other way round, or just to the side. 2 robots finish between Lex and Ty. So Lex and Ty have to be on the extremities. So it's either this or the mirror image. Ray didn't finish second, so it has to be the mirror image then. Okay, let's just double check. 1 robot finishes between Ray and Lex. Yep. 2 robots finish between Lex and Ty. Yep. Ray didn't finish second. Okay, nice and easy. The same 4 robots race again. This time, Ray isn't first and Ty isn't last. Lex doesn't place next to Ty or Ray, and Marv finishes ahead of Ray. Which of these clues do you think is the most helpful to start with? Okay. Right. Has this got anything to do with where they finished previously, or is this a completely separate thing? Right, so it's saying that they race again, so it's obviously completely separate. So Marv finishes ahead of Ray. That only tells us that Marv can't finish in 4th, which doesn't help too much. Lex doesn't place next to Ty or Ray. So that means that Lex would have to finish either first or last, I think. If Lex finished in the middle, then he would have to be next to either Ty or Ray. So this will tell us exactly where Lex finishes, almost, either first or last. Ray isn't first, Ty isn't last. So that just tells us that Ray can finish in one of 3 places and Ty can finish in one of 3 places. So I think it's the middle one. Yeah, happy days. Arrange the races in order they finish. Remember, we have these clues. Ray isn't first and Ty isn't last. Okay. Lex doesn't place next to Ty or Ray. So Lex has to finish first or last, with Marv next to him. And Marv finishes ahead of Ray. So it has to be Lex, Marv, Ty, Ray. Okay, not too bad. The final race is among 5 robots. Ray finishes faster than Marv. The smallest difference in finishing times was between Ray and Lex. The largest difference in finishing times was between Lex and Ty. So you would assume that the smallest distance and the largest distance is going to be somewhere along that lines. Mig finishes either first or third. So let's just put Mig in there. Ray finishes faster than Marv. Okay, well that fits. Ray finishes faster than Marv. Correct. The smallest difference is between Ray and Lex. Okay. That's obviously joint difference between the others as well, though, so it's possible that that's incorrect. Unless it's only saying the smallest difference between... I'm not sure on that one. The largest difference between Lex and Ty. Mig finishes either first or third. I think that's correct. Hooray, happy days. Happy days. Okay, we've completed our first lesson. So I'll quickly jump into the next one. Okay, next up. These next ordering problems will have multiple possible solutions. You'll deduce how many solutions are possible through critical reasoning and count them up. The Evil Core robots continue their physical fitness evaluation, but it's day 2, and they are getting tired. Their self-reporting of results, while still accurate, is even spottier. Based on the limited information, it's impossible to tell exactly how the races ended up. There are multiple possible outcomes. Okay. Marv, Ray and Ty race. They only report that Ray finishes ahead of Ty. How many different orders could the racers finish? So it could be that, or that, I think. Hooray. The 6-way race is trickier to deduce. They report these. Ray and Lex finish with 3 racers between them. Right, let's just stick them in. Okay, so it's either there, or the mirror image. Marv and Lex finish with 1 racer between them. In how many different places could Marv finish? Okay, so it's either there or there. So just the 2 middle ones, and then if we do a mirror image, it's still just the 2 middle ones. So 2. Huzzah! In the next race, 5 robots compete. They report these. Marv finishes either 2nd or 4th. Ray finishes either 1st or 5th. Lex finishes either 3rd or 4th. Ty finishes either 1st or 2nd. Mig finishes either 3rd or 5th. Okay. How many different orderings are possible? Right, so if Marv finishes 2nd, then is there any other combinations of 4th? There's only 1. So we know if Marv finishes 2nd, that only 1 other person can finish 4th, which is Lex. And then if Lex finishes 4th, the only person that can finish 3rd is Mig. And then the only person that can finish 5th is Ray. Okay, so that's 1. And then the same thing will apply if we put Marv in fourth. So Marv in fourth, second would have to be Ty, first would have to be Ray, fifth would have to be Mig. Okay, yeah, so 2. Happy days. 4 of the robots compete in a final race. Marv finishes either second or fourth. Ray finishes in either fourth or second. Right, Lex finishes either first or third. Ty finishes either third or first. How many different orderings are possible? Right, so right, each one of these was discounting a different robot. So second and fourth is not the same as third and fourth. So they're not excluding one another. They're leading on to a different one. Whereas these are the same pairs, second and fourth, second and fourth. So they're not actually excluding each other. So I think the answer's 4. Let's test it out. Second and fourth, first and third. So that's 1. But then we can swap these 2 around and that'll make 2. Then we can swap them 2 around, that'll make 3. And then swap them 2 around and that'll make 4. So I'm pretty sure the answer is 4. Happy days. Okay, that was nice and simple, that one was. Okay, I'll quickly jump into the next one. Right then. This lesson focuses on 2 types of information, where the things you're positioning are not located and the relative difference between unknowns, rather than information about specific positions or values. To solve these problems, you'll need to strategically pick out what pieces of information are the best starting points for organising your thinking. This is a critical skill to practice to improve math and logic. Okay. The robots are off to Miami. They will be retrained to run the Evil Core theme park. But first, they all have to get to Miami in one piece. Marv, Ty and Loy are picky about where they want to sit on the plane. Marv does not want to sit on the centre. Ty does not want the aisle. Loy does not want the window. If Marv sits in the aisle, where should the others sit? So Loy does not want the window. Nice and easy. Find another solution not in the order of Marv, Loy, Ty, assuming the same preferences. So Marv does not want the centre and we can't put him in the aisle. So Marv would have to go in the window. Ty does not want the aisle, so Ty would have to go in the centre, and Loy does not want the window. Loy in the aisle. Happy days, nice and easy. How can the robots be seated to satisfy these requests? There is exactly 1 seat between Ray and Meg. Okay, let's just stick them in. So there's exactly 1 seat between them. There are either 2 or 3 seats between Lex and Nook. Okay, so if we put Lex here, then 1, 2, then Nook would have to go there or here. So Lex and Nook have to be in the 2 outside positions. They can't be in the centre. Neither Nook nor Mig is next to the empty seat. Well, if we put this here, that would be next to the empty seat. Okay, this might take a this might take a little bit more effort. Right. In fact, there's exactly 1 seat between Ray and Mig. If I just swap them around and put the empty seat there, there are 2 or 3 seats between Lex and Nook. Right, neither Nook nor Mig is next to the empty seat. I think that is right. Hey, happy days. Right, the plane is taking off and the robots settle into playing some puzzle games on the seat TV to pass the time. In this puzzle, right and left are from the perspective of the viewer. Okay, so that's right, that's left. Chest A has more coins than the chest to the right. Chest B has more coins than the chest to the left. Chest C is not in one of the middle places, so C has to be on the extremities. Chest D has more coins than chest A. Okay, what's the correct order for these chests based on the clues given? Right, well, chest C is not in one of the middle places, so let's just start with that. Chest A has more coins than the chest to the right. Chest B has more coins than the chest to the left. Chest D has more coins than chest A. So, right, let me have a think about this. So, right. So there's only one correct answer, apparently. So if I put A there, then I can't put D there because D has got more than A, and A would have more than the chest to the right, which is incorrect. So if I put B there, B has more coins than the chest to the left, so they can't be next to each other in this order with A on the left. So let's try that. So chest B has more coins than the chest to the left. Well, there is no chest to the left, so that can't be correct. Chest D has more than chest A. So it's possible that chest D has got less than chest B. So you would assume all of this fits the criteria. C is on an extremity. D doesn't say that it's got more or less than B, so I think this is the only possible outcome. Because A can't go there, and it can't go there. So A has to go there. Yeah, I'm pretty sure, unless C can go here, if we put C there, that can't go there because D has got more than it. A can't go there because there's no chest to the right. So yeah, I'm pretty sure that is the only possible pattern that fits the clues, which would mean that B has got the most. D has got the second most, then A, then C. B, D, A, C, I think. Hey! Took me a little bit longer, that one. I just had to make sure that. Okay, now the chests are in the correct order. So that is where I've just put them. Yeah. Which chest has the most coins? I've just worked this out. What did I say? B has more coins than A, has more coins than the chest to the left. So yeah, I think it was B, B, D, A, C. Hey! We'll tackle both non-numerical and numerical logic problems in this course. In the numerical problems, a single clue can be used to describe a pattern that holds for all of the robots or objects in the problem. Okay. For example, these 5 robots each need to keep their own temperature stable. They easily get overwhelmed if surrounded by too much heat. Seat the remaining robots so that no robot is seated between 2 robots that are hotter than it. Okay. So it just has to go in descending order, right? Yep. Okay, after a few hours in flight, these robots need you to reseat them in a different order so that there are exactly 2 robots seated between the 30 and the 90. Okay. 2 robots between. No robot is between 2 robots that are hotter than it. Okay. The 70-degree bot has already chosen a seat and can't move. Okay. No robot is between 2 that are hotter than it. So if we did that, I think that fits all the criteria. Pretty sure that fits all the criteria. Happy days. Nice. That one wasn't too bad. I've got a feeling it's going to get a little bit harder soon, though. I'm pretty sure they get harder as you go along. So I'll quickly jump into the next one. Right. In this lesson, you're going to find out who is telling the truth and who is lying. Okay. Along the way, you'll unpack a useful technique for extracting information from any statement, even a lie. Okie dokie. Some of the robots are malfunctioning and have turned into liars. This is a disaster for Marv, who dreams of running the theme park one day. He wants to prove that robots, even depressed ones, can run the theme park better than humans. He needs to identify the malfunctioning robots and get them fixed. There are now 2 types of robots in the theme park. Truthful robots will only make true statements. Okay. Lying robots will always lie. Right. Okay. Use the interactive to identify each robot as truthful or lying. We are both truthful. Well, that can't be true. at least one of us is lying. Okay? I think it doesn't. Does it say that one of them has to be lying? In a minute. Right, we are both truthful. One of us is lying. Right. So that one cancels out this one if I put truthful. So yeah, this has to be the only correct answer. Right, Marv encounters 3 more robots that are all accusing one another of lying. Remember, truthful robots only tell the truth, lying robots only lie. Use the interactive to identify each robot as truthful or lying. Okay. Bo is lying, so let's assume that Ada's telling the truth. Ty is lying, which would mean Ty is telling the truth, and that Bo is lying. Okay. Ada and Bo are both lying, so this can't be true because we've selected Ada as lying. So that has to be lying, which means Ty is lying. So, oh, wait a second. Ty is lying. Ada and Bo are both lying. Bo is lying. Right, I think that's the answer. Happy days. Okay, what's next? One of Marv's tasks this morning is to retrieve the master key to the park and deliver it to the HQ. That's been made harder by these lying robots. He knows that exactly one of these 3 Vault robots has the master key to the park. Only one of the robots is telling the truth. Okay, only one of the robots is telling the truth. Okay. Use the interactive to identify which robot has the key or doesn't have the key. Okay, so let's say he's got the key. Only one of them's got the key, haven't they? Yeah, only one robot has the key, and only one robot is telling the truth. Okay, so let's assume that IG has got the key. I have the master key, which means that the other 2 must be lying. I do not have the master key. Well, they can't both be true because only one of them is telling the truth. So IG can't have the key. Right, I do not have the master key, so that would be a lie. I have the master key, so that would be a lie. IG doesn't have the master key, so that would be the truth. So lie, lie, truth. Okay. I'm pretty sure that's the answer. Let's just double check. So if Jet has the key, IG doesn't have the master key, so that's true. I do not have the master key, so that's true. So we can't have 2 truths, so that is the answer. Happy days. Right. These next 4 robots have the ability to dispense the coins that theme park visitors receive as prizes. Here's what Marv knows. Each robot dispenses a unique coin. Only one of the robots is labelled correctly. Okay. The silver robot dispenses jade coins. Right, so we can click that then. The gold robot is incorrectly labelled, so that can't be gold. So it can't be jade, so gold has to be either silver or copper. Okay. Select the coins until each robot is matched with its correct coin colour. Each robot dispenses a unique coin. Only one of the robots is labelled correctly. So that's incorrect. That's incorrect. So one of these has to be correct. It can't be jade because jade has already been used. So the copper has to be the correct one, which means the gold has to be silver, which means jade has to be the gold. Happy days. Right then. Another 4 robots are labelled the same way. Once again, each robot dispenses a unique coin and only one of the labels is correct. Marv remembers that he has the master key and can open up the robots to see which coins they have, but they would prefer that he didn't. In the worst case scenario, in the worst case, how many robots would he need to open to find out which robot contains the coin it contains? It says it contains. Right. Oh, God. I think this is where the game is going to start getting a bit more confusing. We don't have interactive stuff. So I think this is where pen and paper is going to come into play. Right, each robot dispenses a unique coin. Only one of the labels is correct. Marv remembers that he has a master key and can open up the robots to see what coins they have, but they would prefer that he didn't. In the worst case, how many robots would he need to open to find out which robot contains the coin it says it contains? Okay, so in the worst case, so let's say we open up gold, and the worst case scenario is it doesn't have gold in. So let's say it has silver. So then if we open up, right, now would it be a good idea to open up the silver or not the silver? We know that the silver hasn't got a silver in because the gold has got the silver in. So let's say we opened up the copper next. So the copper could have either gold or jade, because if it had copper, then this wouldn't be the worst case scenario. So let's say it had gold in it. Then the 2 remaining coins would be jade and copper. We know that it can't be copper because we've already opened copper. So jade would have to be the answer. And we would get that by opening up 2 of the robots. So the answer's 2. Happy days. Okay. Right, well, I do need the toilet, but I want to carry on. I really want to carry on. I'm going to do one more, and then I need the toilet. So I'll probably call it an end to this video after the next one. Right, next one, worst cases. When you're looking for a logical strategy that will always work, it's often useful to consider the worst case. It can make sense to think about the worst case even when something good is happening, like when you're about to get free socks. Marv has noticed that all of the human visitors at the Evil Core theme park are wearing clothes. He thinks it might make the guests more comfortable if the robots wore clothes too. He knows Evil Core has branded socks in storage and goes to find some. There are red, yellow and blue socks. The sock container is up so high that Marv has to awkwardly reach up and over the top without seeing inside, and he can only reach one sock at a time. Draw the first sock. It's blue. Marv wants a matching pair of socks really badly. What's the worst thing that could happen on the next draw? Okay. Drawing a red or a yellow sock. Marv tries his luck. Draw the next sock. It's red. So Marv still has no match. Draw the next sock. It's yellow. Marv seems to have some bad luck. How should he feel about the next sock? Well, he's obviously going to get a match, but he might not get his blue sock. He wanted a matching pair of blue. Where's that as an answer? Right, okay, well, yeah, I suppose that's the best answer, but it's not the ideal one because he wanted blue. Okay. You could guarantee that drawing 4 socks gives Marv a match by thinking about what would happen in the worst case. If unlucky, the first 3 socks would be different, but guaranteed Marv will get a match on the 4th. Okay. After admiring his new stylish yet understated socks, Marv resolves to dress the rest of the robots working in the theme park. Marv sees that the boxes in the storage room are sitting near labels that say how many shirts, pants, and socks they contain. He needs to figure out which box is which and attach the correct labels so that another, hopefully taller robot can deliver the right number of items to various groups of robots. One box has 50 shirts, 10 pants, 2 socks. The other box has 10 shirts, 40 pants, and 12 socks. To figure out which box is which, Marv is going to take items out, one at a time, from one of the boxes. Marv draws three times, not items, sorry. Marv draws 3 times, and they all turn out to be socks. Will Marv be able to tell which box? Yeah, obviously, because this one's only got 2. With only 3 draws, Marv was able to figure out what was in each of the boxes. That was the best case scenario. But let's think about the worst case scenario. The next pair of boxes have the same labels. In the worst case, how many items does Marv have to draw to be sure what box is what? Okay. Right. So 2 socks, 10 pants, 10 shirts. So 10, 20, 22, 23. It's got to be 23. Hasn't it? Because it's possible that he can draw 10 shirts and still not know. 10 pants and still not know. 2 socks and still not know. That's 22. So he needs to draw a 23rd. Yeah, it's got to be 23. Right, this time Marv was unlucky. After 22 draws, Marv got 10 shirts, 10 pants, 2 socks. Can Marv tell which box he's drawing from? No. It could still be either at this point. This is a terrible run of luck. In fact, it's the worst case scenario. It's a shirt, giving Marv 11 shirts. From which box is he drawing from? The box with 50 shirts. On the next shelf over, Marv sees 3 more boxes, and someone has left a warning note. All of these labels are on the wrong boxes. Oh god. Okay. For example, box A does not have 100 shirts. Oh god. I think this is where it's going to get tough. Right, so one of these has to have 100 shirts. Oh, sorry, one of these has to have 100 shirts. My bad. Marv is running out of time and wants to be sure which box has 100 shirts with just one draw. Which box should he draw from? Right. Marv is run out of time. Wants to be sure which box has 100 shirts. Well, he knows this one hasn't got 100 shirts. Oh, God. And he knows that this one is incorrect because all of the labels are incorrect. So this one can't have... Oh, sorry. This one can't have... Oh, God. Inamin. Wait a second. Oh, God. Oh, it's a terrible time to need the toilet. I knew I shouldn't have done one more. Oh, okay, okay. Is it not enough information? Marv is running out of time and wants to be sure which box has 100 shirts with just one draw. Which box should he draw from? Well, there's no point in drawing from this one. If he draws from this one, oh no, because that could have... It's possible that both of these have got shirts in, and that this is the one with pants in. And if he draws one shirt from either of these, it's not going to tell him which is the one with 100 shirts in. It's got to be not enough information, surely? Incorrect. No, my first mistake. Why is it box B? The label on A incorrectly states 100 shirts are inside it. So, those items must be in B or C. Okay. Let's suppose Marv draws from an item from box C and it turns out to be a shirt. This could be because box C is in fact the box with only shirts or the box with both pants and shirts. The information he gets here doesn't tell him anything for sure. Okay, and that's why I was saying it wasn't enough information. Let's suppose instead he draws an item from box B. Box B could be the box either with all shirts or all pants. So drawing a single item will tell him for sure which it is. Yeah, but that's still only a 50-50 chance that you get the right box. If you get pants, you'll say for certain that it's the box. Right. Well, yeah, but it's a 50-50 chance that you get the correct box, so you're not going to be sure to get the correct box. I think I've just understood the question wrong. Because the way I was reading it was, are you going to be sure that you're going to get the correct box, which will identify which is the one that's got 100 shirts in? Which the answer would be no. So I think I've read the question wrong. So yeah, oops. Yeah, drawing from box B is a good idea because we know B must have either only shirts or only pants. So the result will unambiguously tell you. Oh, in a minute. We don't know that. That's not... No, because it's possible that it box A might have only pants. Not, and so saying that box B must have either only shirts or only pants is... wait a second. If this had only pants, then that would mean that this is telling the truth if it didn't have only shirts. Right, let me have a think about this. So if that was pants and you chose this box, then you would know that this is the one. No, you need to find out which is the one with only shirts. But this one could have the shirts, and this one could have the shirts. So if you manage to get the one with only pants in, then yeah, fair enough. But if this was the one that had 100 shirts, yeah, so basically I've just understood the question wrong. Yeah. There is no way to guarantee that you'll get the question right. Maybe. Yeah, I'm understanding it, I think. This is a tough one. This is properly a brain teaser. Yeah, this is so C would be here, which means A would be here and B would be here. So this has to be either A or C. Yeah, so choosing this one, because it's the one with the mix and you know that it's wrong, you know that you're guaranteed to be able to find out. God damn it, I figured it out. Damn it. Well, at least I've figured it out now. Damn it. I could have got that question. Right, Marv is down to the last 3 boxes. Once again, he doesn't know which labels match up to which box. His battery is running low, so he decides he's just going to draw items from one box. He jiggles 2 of the boxes to check their weights and deduces that box A has more items than box B. Okay. What's the smallest number of items Marv needs to draw to be guaranteed to be able to tell which box is which? Right. Is it 21? In a min. Let's see if we can work this out. So he knows that this has either got pants or shirts in. It can't have both because it's heavier than this. So that one has to be either a mix or the same one. So if he knows that this can only be one of these, he only needs to draw 2 items out of it to know. In a minute, what is the question? Was to be guaranteed to tell which box is which. Then he would guarantee, right, he would guarantee what is in this box, but he still wouldn't know what is in these 2 boxes. So he would need to draw the smallest number of items he needs to draw. So 2. Maybe I don't have to draw anything from this box then. Figuring out these 2 boxes would tell me what this box is. So it's just between these 2 finding out. So if you just draw 2 items out of here, that would tell you, oh no, sorry, you could end up with 2. The smallest number of items, right. This, right, okay. The smallest number of items is still 2. This isn't a worst case scenario question, is it? It's a smallest number of items question. So if I drew 2 out of here, then I would find out which of these is which, and if I drew 2 Wait a second. If I drew... No, see, I'm still thinking in terms of worst case scenario. Best case scenario, if I drew one shirt out of here, then it would tell me that this is the pants, this is the shirts, this is the shirts, and then I only need to draw one more out of here, because we're talking about best case scenario now, not worst case scenario. Wait a second, no. Are we talking about best case scenario? No, we're talking about guaranteed. That is the important word, guaranteed. So I would need to draw 11 items out of one of these boxes to be able to identify exactly what's in all three. I think. Hey, it took me a while. It was all about reading the question properly. That's what it's about, reading the damn question. Right, Marv ends up needing to draw 11 times. Bad luck. He's drawn 10 shirts and 1 pair of pants from box C. That should be enough to identify the boxes. Remember these. One box has 50, one box has 40, one box has 10 and 10. Box A has more items than box B. Which box contains only shirts? Okay. Right, so he drew from box C. So box C has got 10 shirts and 1 pant. So box C has to be the combination one. This box is heavier than box B. So this has to be the only shirts. So it has to be A. Thank God for that. Right, all done. I can finally go to the toilet. Well, I enjoyed that. That was different. A bit different than shooting people. So yeah. Let me know if you enjoyed it. If you want to see some more of these logic questions, I've got a feeling the rest of them are going to be significantly harder than this bunch, because I think we're up to the stage now where they're probably for brainy people. So yeah, let me know if you want to see some more, or if you want to see some maths-based ones or science-based ones. I don't really know what there is to go through, to be honest with you. I know there's at least 100 different categories, so yeah, let me know. And I hope you enjoyed it. So cheers for watching, take care, and I shall see you soon.